I'll show you how to create a revolution object of a function in TI-Nspire. First of all, I'll begin by dividing my screen area here in 3 sections. First of all, I'll add a little node area to define my function. And to do that on a PC, I press Ctrl M and define the function by typing f of x equals colon equals minus x squared, for instance, plus 2x. So I press enter and my function is defined. Yes, let's make a little graph here of that one. F of x. Here we go. So we can see that we have this area encapsulated in here. So I need to know the intersections here, the roots of this function. So let's figure that out. We could do that by solving. F of x equals 0, point x. Yes, of course, that's 0 and 2. So now we know our limits, and it's actually quite easy to figure out this volume, because we have a very simple formula, and that's just pi times, and then we need our limits here. That's from 0 to 2, that's 0, 0, and then the function squared. So squared here, dx. So we just take this integral of the function squared, multiplied by pi, and here we go. So that's the volume. But how can we draw this? How can we visualize this? We add one more graph, so we can draw 3D graphs in TI-Nspire. So, but we need a 3D here. But this entry here is for ordinary functions of 2 variables, and that's not what we're dealing with. So we need to use a parametric entry. So we go up here, entry, and then we choose parametric. And of course, to make this revolution, for each and every x value here, we'll have circles. First tiny circles over here, and then larger and larger circles. So in a parametric function, that would be a cosine sine function. So that would be like sine cosine t and sine of t. But that will just give us circles. So we need to multiply this by the function value right here. So this function is now a function of u multiplied by this, and up here we just have u, that meaning the x value, so to speak, will be u. So we press enter, and now we see we actually have this volume down here. So we got it up till something like 2 pi. We just want it between 0 and 2. So let's make those changes in a second. But as you can see here, it's a very good visualization of what is going on when we make this revolution. So let's look at this box here. We can change the range settings. I opposite clicked on the box, and then I've got this one here. So I need to figure out my x value, which is this direction over here, meaning I only need from 0 to 2, but let's have it from -1 till 3. And also the y-axis is this axis here. that means that is from the function value maximum, which is around 1, up. No, yeah. So let's just have it from -2 up till 2, just to have a little space around. -2 up until 2. And this we change manually. So here we go. Oh, still not the correct range. This is just looking closer at the box. We still have this, so what to do? Yes, that's up here. So where we enter it, we just double click up in this area and go into this history menu. We'll find the function we just entered and these tiny dots here. So yes, the revolution needs to be from 0 to 2 pi, but the U value is only from 0 to 2. Here we go. Now we have the correct ones. So you can also change here if you want another color, for instance, fill color. Let's have a orange, and even the lines could be changed, and also you could change all kinds of attributes if you, for instance, want just a shaded version or wireframe, but in this case I think I prefer this one because it's easier to see what is going on. You could also change the resolution here, and also the transparency if you want it more or less transparent. For instance, if I want 70, I just press 70 and then you can see it is definitely more transparent, almost too much. So let's attributes, let's change this to 40, for instance. 400. Yes, please, thank you. I want 40. Here we go. So that's how you make a 3D visualization of this revolution object when you have an ordinary function with one variable as a parametric visualization. Yep, that's it.